Hello, welcome to A Demola, and today's video we're going to be talking about mass spectrometry. Can't lie, this is a bit of a scary one, but what I'm going to do is just break down what's really happening, and then we're going to go into a bit about your key definitions and how to interpret these graphs so you can pick up those marks in exams. So let's get straight into it. Okay, so I'm not sure if I'm ever going to be able to emphasize this enough, but definitions, guys, are so important. So we're going to begin with the definition for relative isotopic mass. This is going to be the mass of an isotope of an element compared to the mass of 1/12 or the mass of a carbon-12 atom. You're going to see 1/12 of carbon-12 all the time. Make sure to remember it. It's always going to be a marking point if they ask you to define one of these terms. The next definition that we're going to get into is the relative atomic mass, the weighted mean mass of all of the isotopes of an element compared to the mass of 1/12 of a carbon-12 atom. Cool. Last definition that we want to do for this lesson is going to be relative molecular mass. Might also be called relative formula mass, depending on how big the compound we're talking about is. But this is the sum of the relative atomic masses of all of the atoms in a molecule or in a compound. So, those are going to be your key terms for this lesson. Make sure to remember these definitions. They're really easy marks to score on the exam. So we're going to move on now. Okay, so like we said, the focus of this lesson is going to be on mass spectrometry. Now, stages of mass spectrometry, do not stress at all. I would say with almost full confidence they will not ask you this on the exam to say the stages of mass spectrometry. However, we're going to address them just so that you're aware of them. So we have this acronym IAD: ionization, acceleration, deflection, detection. And you can see here you kind of inject your sample into the machine, gets ionized. So it's always going to be a +1, always going to be, when you're ionizing it, always going to be a +1, yeah? Then you're going to have acceleration. You're going to make the particles go faster. They normally use like a magnetic field to do this. And then you're going to go through deflection. And this is kind of where you get to tell different molecules. So the deflection is normally to different degrees, different angles, which is going to mean that the time taken to get the detector at the end is going to be different. And because the time to get the detector is different, that's how you can get your value. That's how you kind of determine what molecules in your mass spectrometer. Cool. Now, really what we want to focus on this lesson is analyzing these graphs. So these graphs are crucial, really important in terms of this topic. Now, y-axis, relative abundance mass, and if we look to the x-axis, we've got our boy, mass to charge ratio. Remember those axes, really important. And your mass to charge ratio is just equal to the relative formula mass or the relative isotopic mass. Literally, we're chilling. Cool. Key terms in your mass spec: base peak, the peak with the highest relative abundance. All you need to know about the base peak. It's the one with the highest relative abundance. Another key term that we're going to have is your M+ peak. The molecular ion peak is what it stands for. And this is going to be the full molecule. So when we put a molecule in a mass spec, it can kind of fragment. But your molecular ion is going to be the one with the highest mass to charge ratio. So the whole molecular ion, when it was ionized, it didn't break apart, it didn't split at all. So your whole molecular ion got through to the detector. Now, phenomenon we like to call the M+1 peak is also important to note of as well. Your M+1 peak is usually caused by carbon-13. So because of the presence of carbon-13, you might get an M+1 peak, which is going to be one mass to charge unit higher than the molecular ion peak. Okay, now in exams, this is where you're going to make the big bucks. Calculating the relative atomic mass. Important formula. The relative atomic mass is going to be equal to the relative abundance of the first isotope multiplied by the mass of the first isotope plus the relative abundance of isotope 2 times the mass of isotope 2. Now, doesn't have to be 2 isotopes, can be however many isotopes there are that we're concerned with, yeah? So if we go up to flipping 10, whatever, but I've just left out 2 for this one. You divide all of that by 100, yeah? Fantastic. Now, we've got a worked example here. It's just so that you can see kind of the rationale, the thinking behind all of this. So, you see your mass spectrometry here. We've got a peak mass to charge ratio of 35 and one at 37. So, our relative abundances are labeled on the top there. So we're going to input it into the formula. And should I mention we're doing with chlorine. Cool. Now, 75 abundance multiplied by 35, the mass to charge ratio, plus 25 relative abundance times 37 mass to charge ratio divided by 100 gives you an answer of 35.5. So 35 grams per mole must be the relative atomic mass of chlorine. So yes, absolutely they can give you the graph and tell you to analyze it. What they can also do is to give you a table. They can give you a table and tell you to analyze it. And that's kind of what we've done in this example here. So we've got magnesium. You can see its isotopes. We've got 24, 25, 26. Bonus for you if you can work out how many protons and neutrons and electrons are in each of them, building off of our last chemistry video. But you've got the relative abundance of each of them. So yet again, we're not going to panic. We're going to put it into the formula, bish, bash, bosh. 79%, or 79 is the abundance multiplied by 24, plus 10 times 25, plus 26 times 11, divided by 100. And I've put it in that way because I think this is what you should put into the calculator, just so that it doesn't get confused. So much better to be a bit more pedantic, make sure you're getting the marks. But the answer is 24.32. And if you look to your periodic table, they will say that the relative atomic mass of magnesium is 24.3. So everyone, question time. We've got 3 questions here for you to try. 1 multiple choice, 2 calculations. So take a pause of the video, have a go, and then we'll get into explanations after. Okay, and here are your answers. So we're going to focus on question by question. So we look at question 1. A is correct. The n plus peak is the highest mass to charge ratio, as we've said. Let's prove all the other ones are wrong. B. The base peak represents the isotope with the highest mass. That describes your n plus peak, doesn't it? So you look to the far right, the highest mass to charge ratio, the highest mass, n plus peak, not the base peak. C would be describing your base peak. The most abundant isotope is going to be your base peak, the tallest one. And the base peak always the same as n plus peak. Although they can be the same, it's not always, which is why D is wrong. Cool, so look at question 2. Again, we're using the formula. We're doing what we've done throughout this whole lesson. Look at the relative isotopic mass, look at the abundance, put them into the formula, put them into your calculator, get your answer, happy days. Yep. That's all there is to that one. Now, I said the definitions are so important, guys, because they are 3 marks for a definition that will take you a minute to learn. Please, 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 please learn the definitions, because it's not worth throwing away 3 marks for. Again, calculation, although this one, the numbers are a bit more complex. It's pretty much the same thing that we've been doing. Put in the isotopic mass, put in the abundance, multiply them together, add them all up, and then get your answer. I'm not sure if I specifies how many decimal places to do. I would say make sure to look at the question. Make sure to look at the question. They probably will tell you. If they don't, either do either 1 more decimal place in the question or the same amount. So yeah. Okay, so we're getting towards the end of the lesson, and that means it's time for the A-star tips. What I would do, guys, you just saw the last one was 3 marks. Please, 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 please learn the definitions. They are not that difficult to learn. They are good marks to get in the exam. Know the formula. This isn't one that you're going to get on your data sheet, I don't believe. So please, please know the formula. Again, I don't think it's a hard formula to remember. Please know the formula. Please be confident in using it. Do practice questions, the whole lot. Understand what your n plus 1 and base peaks mean. But it's so easy to get confused between the 3. So please just be happy with it. Know what causes it. I think you'll be fine. All the molecular ions are +1. I did mention it briefly earlier in the lesson. Please just remember all of them have a 1 plus charge. Yeah. So like even if you have like calcium and they say what's the molecular ion, if it's in the mass spec, it's Ca 1 plus, not 2 plus. Yeah. If it's in the mass spec. Then look at how many decimal places they want you to round to. Guys, it is honestly devastating when you do the question, do all the workings out, and you've missed it on 1 mark because you didn't round to the right decimal places. Guys, and it seems like, oh, it's only 1 mark dropped. Please, 1 mark can be the difference between an A and an A star. It can be the difference between an A and a B. Guys, please just look at how many decimal places in the question. You don't want to drop a silly mark for that. Now, what do you not do? Do not assume the n plus peak is the tallest. This happens all the time. It's not the tallest, it's the one furthest to the right. Yeah.
Don't include ions with multiple charge. Like I just said with the example of calcium, it's easy to just do that because that's something that you know. But in mass spec, all of them have a 1 plus charge. Don't memorize different mass spec. This is more of an issue for module 4, which we'll get into when we get there. But don't memorize them. Look at what's in front of you and try to analyze that. And also, I would recommend when you're doing calculations, do not round early. If you need to, use the answer button on your calculator. Just guys, it's again, if you round too early, you might end up getting the wrong answer, and that's really not nice. So just round at the end; it will be better for you. Okay, end of the lesson. Thank you guys so much for watching. I hope that after that you've got a better understanding of mass spectrometry and you feel a bit more confident in approaching the questions. Feel free to like, subscribe, drop any questions in the comments below. I'll do my best to answer. Thank you so much for watching. Bye.